Petrography. Sedimentary rocks. Deposits. Sediments are formed by the deposits of materials. For a sediment to be formed, erosion of pre-existing rocks must have occurred, and also the subsequent transportation to the area of definitive sedimentation, called the basin. Once the rocky materials have been deposited, they undergo crushing, cementing, and recrystallizing processes, which result in sedimentary rock. Sedimentary rocks. Crushing. Crushing consists of the materials being flattened by the weight of the materials that are deposited on top. The sedimentary mass is reduced in volume, porosity, and permeability, and it even loses some of the water which it retains within its grains and fragments. Sedimentary rocks. Cementation, which can take place at the same time as crushing, occurs when new minerals are precipitated among the detrital grains, joining together with them, cementation, and filling the interparticle spaces. The rock loses porosity and permeability. This is the evolution of the Villamayor sandstone. Sandstones. Bearing in mind the composition of the grains and the proportion of the matrix, the following types of sandstone can be distinguished. Quartz sandstone. Quartz is predominant and the matrix is 15% or less. The size of the grain can vary, as can the composition of the cement. Lithic sandstone. Made up of quartz grains and a smaller proportion of rock grains. The matrix is less than 15%. Feldspathic sandstone. Formed of quartz grains and a smaller proportion of feldspar. The matrix is less than 15%. Grey wackas. Quartz, feldspar, or slate may be predominant, and the matrix is over 15%. The Villamayor sandstones used in construction can be classified into two types. Those that have less matrix, under 15%, are classified as feldspathic lithic sandstones because of their substantial feldspar content. Those that have over 15% matrix are classified as lithic feldspathic grey wackas. Composition of Villamayor sandstone. In the petrographic composition of Villamayor sandstone, we can find quartz, feldspar, mica, rock fragments, clayey matrix, and cement. Here we will look at these elements one by one. Quartz is identifiable by its angular-subangular grains. It's highly stable in the face of chemical meteorization. It is the main component and is characterized by monocrystalline grains and a smaller amount of polycrystalline grains with a subangular outline. Feldspar, including both potassic feldspar and calcium-sodium feldspars. This component is less stable than quartz and undergoes an illite alteration, a type of clay similar to micas, a process known as ceratization, which is more marked in calcium-sodium feldspars. Mica is present in the form of muscovite, biotite, and chlorite. Muscovite is reasonably stable, while biotite is usually partially altered to chlorite. Chlorite forms a fundamental part of chlorite schist fragments. Rock fragments, especially of slate schist type, are present in the sandstone composition. Some rock fragments are greatly altered and are confused with the clayey matrix, in which case they are called epimatrix. Clayey matrix. made up of particles of under 0.06 millimeters, form a film that covers the grains in the cleanest sandstones, while in the ones that contain more matrix, the clay particles form aggregates. Cement does not exist as such, which is one of the characteristics of the texture of Villamayor sandstone. The grains are joined by the effect of the clayey matrix, which in the case of sandstone with little matrix forms a covering around the grains, joining them with an electrostatic force. In some places carbonates can be found, replacing the matrix on the outside of some grains.